Welcome to Unit 4, Functions. This is Lesson 2, Function Notation. Our learning goal today is to learn about a handy way to refer to and talk about a function. We have 3 learning targets today. As we go through the practice problems, these are the 3 things you want to keep in the front of your mind. If at the end of the lesson you don't feel comfortable making any of these statements, please ask for clarification so that you're prepared moving forward. Learning target number 1, I can use function notation to express functions that have specific inputs and outputs. Learning target number 2, I understand what function notation is and why it exists. And learning target number 3, when given a statement written in function notation, I can explain what it means in terms of a situation. For glossary terms, we have dependent variable, a variable representing the output of a function. This variable is going to be calculated, and that value that gets calculated depends on what value is chosen as the input. Therefore, it is the dependent variable because it depends on the input. Next, we have function. A function takes inputs from one set and assigns them to outputs from another set, assigning exactly one output to each input. And that is the important part. In order for something to be considered a function, every unique input has one and only one unique output. Next, we have function notation. Function notation is a way of writing the outputs of a function that you have given a name to. If the function is named f and x is an input, then f of x denotes the corresponding output. Independent variable, a variable representing the input of a function. It is independent because you are the one choosing what that input is going to be. It doesn't depend on anything else. Now we can start the practice problems for lesson 2. The height of water in a bathtub, W, is a function of time, t. Let P represent this function. Height is measured in inches and time in minutes. Match each statement in function notation with a description. So, first we need to talk about function notation. In function notation, we have the name of the function, in this case, P. Inside parentheses, we have the input, in this case, T, and it equals the output, in this case, W. So anytime you're looking at this, you need to be reading this as P of T equals W. And then there's a few things to make sure that you pay attention to. We see that height is measured in inches, And we see that time is measured in minutes. So now we need to start looking at these and deciding which function notations go with which descriptions. So here we are saying P of 0, 0 is t, which is time, and time is in minutes. So we want 0 minutes, and then it equals w, so 0 is w, and w is the height measured in inches. So 0 minutes, 0 inches. Now I look through here, and I see number 2, the bathtub starts, that would be 0 minutes. The bathtub starts out with no water. That would be 0 inches. So A is going to match with 2. Now we look at B. P of 4, again 4 is time measured in minutes. So we have 4 minutes, and 10 is W, which is the height of water measured in inches. So we have 10 inches. Now I look through my descriptions, and what I see when I look at number 4, the height of the water is 10 inches after 4 minutes. So B matches number 4. Now we look at C. P of 10, 10 is the input, that is time, and time is measured in minutes. So 10 minutes equals 4. 4 is the output, that is W, which is the water height measured in inches. So we have 4 inches. And when I look at my remaining choices, number 3 says after 10 minutes, the height of the water is 4 inches. So C matches number 3. And finally, D, we have P of 20. 20 is the input. The input is time measured in minutes. So that is 20 minutes. Equals 0. 0 is the output. The output is W, and W is the height of the water measured in inches. So that's 0 inches. Number 1 is the only choice left, and it says after 20 minutes, the bathtub is empty. That does match, so D matches number 1. If you have any questions about how to read function notation and match it to a description, please ask for further clarification. Whether you're in class or leaving a comment online, please ask for that clarification that you need. Our next practice problem, function C takes time for its input and gives a student's Monday class for its output. So I just want to make sure you remember function notation is name, in parentheses, input, equals output. So based off of what they just told us, the name is going to be C. The input is going to be time. And the output is going to be the class. So now we can look at the questions. Number 1. Use function notation to represent a student has English at 10 o'clock. Well, if I fill in what I just came up with, I have C. In parentheses, I want to put the time, and that's 10 o'clock. So C of 10 o'clock equals the class, and they tell us that class is English. So this is how we take a description and write the function notation that represents it. For number 2, we're going to do it in the opposite direction. Write a statement to describe the meaning of C of 11:15 equals chemistry. Well, now 11:15 is going to be the time. Chemistry is going to be the class. So I can just replace the class and the time from number 1 with the class and the time they give us in number 2. So we're going to write a student has chemistry at 11:15. So in the first example, we took a statement and wrote function notation to represent it. In number 2, we did the opposite. We took function notation and we wrote a statement to represent it. If you have any questions about how to do either of these, please ask for further clarification. If you're watching this online, leave a comment and I'll get back to you with any clarification that you need. Our next practice problem gives us a graph on the right. We can see that the x-axis is labeled time in seconds, and we can see that the y-axis is labeled distance from post in feet. Function f gives the distance of a dog from a post in feet as a function of time in seconds since its owner left. Find the value of f of 20 and of f of 140. So, let's make sure we understand a couple of things. Anytime we see as a function of, that is, output is a function of input. And we can see from the labels here, our output is distance. Our input is time. Now, when I use function notation, I have name of input equals output. So in this case, the name is F. The input is the time, so that is F of 20 seconds. I need to go over to 20, go up until I hit the line, and then look to the left and find out that my output is 3 feet. So that is the first answer. Next, we have F of 140. So that means F of 140 seconds equals, we go over to 140 seconds, we go up until we hit the line, and then we look to the left, and we see that we are between 3 feet and 4 feet, so we will say 3.5 feet. And now we have both of our answers. If you have any questions about how to use function notation and the graph of the function to find the outputs, please ask for clarification. If you're watching this online, please go ahead and leave a comment, and I'll get back to you with further clarification. Our last practice problem, function C gives the cost in dollars of buying n apples. What does each expression or equation represent in this situation? So we have some new wording here. It says function name gives, whatever it says right after that is the output of the input. So in this case, the output is going to be the cost, and the input is going to be the number of apples. We also already talked about function notation. Function notation is name, input in parentheses, equals output. So, as we look at these, number 1 says function C, the input is 5 apples, equals, the 4.50 is the output, and we said that the output is the cost in dollars. So 5 apples cost $4.50. Now, number 2 is just a little bit different. We have an input, but we don't have an output. But we know that that output is still going to be the cost in dollars of buying that many apples. So here we would say that this expression represents the cost of buying 2 apples. And we just leave it at that because they didn't actually give us a dollar amount. So if you have any questions about this practice problem or any of the practice problems from this lesson, please ask for further clarification. If you're in my class, simply use class time to ask me these clarification questions. If you're watching this online, drop me a comment. I'll get back to you with any clarification that you need. I'd like to ask you to take a moment, hit the subscribe button so that you'll be notified anytime I upload a new video, and give this video a thumbs up if you found it helpful. That way other people can find these videos and get the help that they need. I look forward to seeing you again in the next lesson.